Hello students, let us see the syllabus of MSc Chemistry first year semester first Analytical Chemistry today. Analytical Chemistry Unit I. Introduction and Statistical Analysis A. Introduction to Analytical Chemistry. Types of analysis: qualitative and quantitative. Classification of analytical methods: classical and instrumental. Basis of their classification with examples. B. Statistical analysis and validation. Errors in chemical analysis. Classification of errors: systematic and random, additive and proportional, absolute and relative, accuracy and precision, mean, median, average deviation and standard deviation. Significant figures and rules to determine significant figures. Calculations involving significant figures. Confidence limit, correlation coefficient and regression analysis. Comparison of methods, F-test and T-test. Rejection of data based on Q-test. Least squares method for deriving calibration graph. Application of Microsoft Excel in statistical analysis, statistical functions and spreadsheets in MS Excel. Validation of newly developed analytical method. Concepts and difference between sensitivity, limit of detection and limit of quantification. Role of noise in determination of detection limit of analytical techniques. Certified reference materials, CRMs. Numerical problems. Unit 2, Separation techniques A. Chromatography. Definition and classification. Techniques used in paper, thin layer and column chromatography. Applications in qualitative and quantitative analysis. B. Ion exchange, principle and technique. Types of ion exchanges. Ion exchange equilibria. Ion exchange capacity. Effect of complexing ions. Zeolites as ion exchangers. Applications. C. Solvent extraction. Principle and techniques. Distribution ratio and distribution coefficient. Factors affecting extraction efficiency. Ion association complexes, chelation, synergistic extraction, pH. Numericals based on multiple extractions. Role of chelating ligands, crown ethers, calixarenes and cryptans in solvent extraction. Introduction to solid phase extraction, SPE, and microwave assisted extraction, MA applications. Unit 3. Classical methods of analysis A. Volumetric analysis. General principle. Criteria for reactions used in titrations. Primary standards and secondary standards. Theory of indicators. Types of titrations with examples: acid-base, precipitation, redox and complexometric. Titration curves for monoprotic and polyprotic acids and bases. Indicators used in various types of titrations. Masking and demasking agents. B. Gravimetric analysis. General principles and conditions of precipitation. Concepts of solubility, solubility product and precipitation equilibria. Steps involved in gravimetric analysis of barium and nickel. Purity of precipitate, co-precipitation and post-precipitation. Fractional precipitation. Precipitation from homogeneous solution. Crystalline, gelatinous and curdy precipitate, peptization phenomena. Unit IV. Electrochemical methods of analysis IA. Conductometry. Concepts of electrical resistance, conductance. Resistivity and conductivity. Specific, molar and equivalent conductance and effect of dilution on them. Measurement of conductance. Kohl-Rauscher's law. Applications of conductometry in determination of dissociation constant, solubility product. Conductometric titrations of different types. High-frequency titrations. Numerical problems. B. Potentiometry, circuit diagram of simple potentiometer. Indicator electrodes, hydrogen electrode, quinhydrone electrode, antimony electrode and glass electrode. Reference electrodes. Calimal electrode and Ag. Silver 1 chloride electrode. Theory of potentiometric titrations. Acid-base, redox, precipitation and complexometric titrations. Nernst equation, standard electrode potential. Determination of cell potential, N, Kf and Ksp. pH titrations. Buffers and buffer capacity. Calculation of pH of buffer mixtures based on Henderson-Hasselbalch equation. If you like the video, then please like and subscribe the channel if you like the information.